Alright boys, this is an HSC question. It's from 2009 or 2010. I think you can look that up on the Border Studies website if you'd like. But it's a curve sketch with the lot. As we see, it's worth 8 marks. The function is fx equals x to the 4 minus 8x squared. Start off with, we've got our roots. Then we've got to show that it's an even function. Then the stationary points, and then sketch fx. So no point of inflection here, no question about when it's increasing or decreasing, and only 1 mark for the curve sketch. But again, however these are formulated, really if you look at it, any curve sketch is probably going to have, almost definitely going to have a question about the turning points, and really after that it's going to be a sketch at some point, and really it's a question of what gets examined. It could be the roots, a point of inflection, increasing, decreasing. Here it's show that it's even, but ultimately it's whatever you get asked to do. So let's have a go at it. Alright, start off, find the coordinates of the points where the graph fx crosses the axis. Well, that's the x-axis. First of all, I'm going to say let y equals x to the 4 minus 8x squared. That's kind of implied anyway by y equals fx. But I'm going to factor that, and that will be x squared outside of x squared minus 8. Okay, well I'm going to let that equal 0. So therefore x equals 0, or x squared minus 8 equals 0. And if x squared minus 8 equals 0, that means x squared equals 8, and x equals plus or minus 2 root 2. So I'll rub that out, that's not particularly neat. X equals plus or minus 2 root 2. Okay, so we've got 3 roots. We of course don't need to find their y values. It also means we don't have to find a y-intercept, because when x equals 0, if I put that in there, y also equals 0. So that's our y-intercept as well. Excellent. So we've got our x-intercepts and we've got our y-intercept. Next, let's go and show that it's an even function. Okay, well I've got fx equals x to the 4 minus 8x squared. Little side point here. It's not enough for a proof, but there's only even powers. Okay, there's only even powers, which means that it is an even function. But of course we need to go put in f of minus x. We've got to show that those two end up being the same. So it's minus x all to the 4 minus 8x minus x squared. Now of course, because we have even powers, those negatives end up becoming positives when we end up with x to the 4 minus 8x squared, which is of course fx. And we need a statement, therefore fx is even as f of x equals f of minus x. And basically what that means is we're saying we've got symmetry about x equals 0, which is of course the y-axis. Alright, next we've got to find our squared, so that means y dash, or dy dx, is equal to 4x cubed minus 16x. Factor it again. I'm going to have 4x hanging out the front, and I'm going to have x squared minus 4 in here, which is 4x, x minus 2, x plus 2. Okay, that means I've got 3 values when that equals 0. I've got x equals 0, x equals 2, and x equals minus 2. Now we'd expect that. We'd expect that because it's an even function. Now we need some corresponding y values. So when x equals 0, we know that y equals 0. When x equals 2, we go put that in, and we end up with 16 minus 32, which is minus 32. we'll end up with the same thing with x equals -2 as well. It's an even function. You could go put that in as well. Now we do need to determine their nature. Let's go find the second derivative here. Y double dash is 12x squared minus 16. Well, let's go and substitute in our x values now. Alright, what we end up with is when x equals 0, or y double dash equals -16, and that means that means our curve is concave down. When x equals 2, y double dash equals 12 times 4, 48 minus 16 is 32. That means it's concave up. And because, again, we've got only even powers here and a constant, we end up with that it also being 32. And it's also concave up. So we should write these out now. What we end up with is 0, 0 at the origin is a max turning point. To -32 is a minimum turning point, and as is -2, -32. That's also is a minimum turning point. Okay. So now it's all that's left to do is the sketch. Okay, so what features do we have? All right, we had roots at the origin at 2 root 2, which is just bigger than 2. In fact, root 2 is 1.4, so it's probably actually not quite there. It's a little bit larger than that. It's probably something like 2.8, 2.9. And we also had one at -2.8, 2.9. We had a turning point at 2, -32. Now, of course, my scale is not going to be perfect here. We had another turning point, -2, -32. That one is a minimum, as is that one. This one here is a maximum. We can see it's kind of taking shape. Positive quartic, so it means when x is very big and positive or very big and negative, we end up with positive values of y. That kind of informs how the shape will look. Let's have a go at sketching it. I think it will look something like this. I'm a little bit off here. Okay, something like that. Now we should label it y equals x to the 4 minus 8x squared. And what you'll notice is we're not asked to do anything with the concavity. You can see just from looking at it where it is concave up and where it's concave down. I'd say it changes concavity about there and there. The problem is if you go check the second derivative, those values end up being a little bit messy. So we aren't asked to find those. We could do though. We could go and test where it's concave up, concave down. Also where it's increasing and where it's decreasing. It'll be increasing everywhere in here. It's increasing through here. It's decreasing through here. Of course, increasing everywhere this way. And decreasing everywhere this way. Not asked for that in the question, but that's what we've got. We should label these things though, I'm sorry. We've got 0, 0, 2 root 2, 0. That's not a comma, that shouldn't be there. Then we've got -2 root 2, 0, -2, -32, and 2, -32. That's our important features to label. Excellent, hope we've got this one. All right, let's have a look. So I'm going to start with some axes. Okay, well, we know I've got a horizontal point of inflection at the origin and a root there. I've got a turn, if that's 1, that's 2. I've got a root about there, a bit more than 2. And if that's -1, -2, I've got another root about there. I've then got a turn at -2, -32. And another one over here, 2, -32. And if you bear with me, I actually realise I've just made a mistake. If we go back to this slide,